Okay, welcome everybody to this webinar for the month of July 2020. We're talking about industrial wireless issues and solutions today. And this is a conceptual presentation, so we're not going to be getting into technical details of specific protocols, but we're going to talk about the issues that are faced when dealing with wireless in industrial deployments today. And this is becoming a big issue, and we'll see why right as we get started, because industrial is really big in IoT right now, and so it's a very important thing. I do want to emphasize that what we're talking about today is not just about Wi-Fi, it's about any kind of wireless that you implement. I'll give some illustrations with Wi-Fi as well as other protocols as we go along. So this is about the wireless technologies that we use in industrial scenarios. And we'll kind of define what we mean by industrial wireless before we get too deep into things. Now, as usual, if you are not following us on Twitter, you can find us at CWNP and at Carpenter Tom. And this webinar is being recorded, so it will be available on YouTube on CWNP TV, the YouTube channel for CWNP there. With that, let's go ahead and take a look at what we're going to be taking a look at today. So first of all, we're going to define industrial wireless. What do we even mean by that? And then we'll get into the issues in industrial environments and solutions to those issues. We're going to look at the big three issues as we go through this today. But first of all, why? Why does this matter? And it's interesting, IoT Analytics reported the top 10 IoT application areas for 2020. And this was released actually in July. And what they found was that manufacturing industrial was at the top, and it's on an upward trend. So of the respondents out of 1,414 different IoT projects, 22% of them were manufacturing and industrial, 15% transportation mobility, and 14% energy, 12% retails, cities, 9% healthcare, and so forth. You will notice that the only ones that were down from the previous survey were cities, sometimes called smart cities, and buildings, and then other. So interestingly, there's been a big movement towards smart buildings and smart cities over the last really 5, 6, 7 years. And what we're seeing is that is beginning to level off a little bit. It's not that there aren't new projects, it's just that there aren't as many new projects because a lot of that has been implemented. And a lot of people don't think of maintenance as a project, right? So if I've already done building automation, then maintaining that does mean that I might have to get new equipment, new devices from time to time. So it doesn't necessarily mean no more sales are happening for smart buildings, but it does mean that new projects being launched in that particular application are a little lower in the recent survey than they were before. However, we see an upward trend across the board in industrial, transportation, energy, retail, healthcare, and supply chain, whereas agriculture has been pretty even. So this is interesting, and it's one of the reasons why today I've chosen to focus on some of the issues that we face in these industrial wireless deployments. Now, not all industrial IoT is wireless. Let me be clear. You can do wired IoT. All IoT requires is that you have internet protocol connectivity. You might not even be connecting to the internet in a lot of projects that people call IoT projects, but you have internet protocol connectivity. And so as long as you have that, whether it's wired or wireless, it's IoT. So just because it's an IoT project does not mean it's a wireless IoT project. But if you look at all the various research and surveys and analysis that's done, somewhere between 85 and 90 something percent of all of these IoT projects are wireless. So that's the move, certainly. Most of these are wireless today. The wired implementations really didn't come under the umbrella of IoT. We weren't thinking of them as IoT. We were just thinking of them as industrial automation. Now, industrial automation is being implemented with wireless IoT, and some wired still, but the vast majority of it is moving toward wireless today, which introduces some unique challenges over wired. Not that wired doesn't have its own challenges as well. So let's define industrial wireless. The first thing is to know that industrial operations obviously are more than 100 years old. So, you go back to before the 1800s, and it was all craftsmen and craftswomen and people who were just making individual one-off products one at a time, and then they were selling those, right? So you had the blacksmith or the individual who makes, what would they call the individual who makes the cart for the horse? I don't know, but they made wagons and wagon wheels. And so people did their own thing, and then they sold that thing. And there were a few companies that started in the 1600s and 1700s that specialized in making something, and they had a lot of people that worked on it, but there really wasn't a mass movement toward industry, toward having a business that hires a bunch of people to produce a product that's going to be sold until the 1800s. So that really started in a large scale in the 1800s. And then industrial automation was the next thing to come along, with saying, okay, instead of having people that are running here and there and everywhere within a manufacturing environment to do all jobs, we're going to instead have it be that we bring the product to the person that knows how to do the job. They do the job, and then the product moves on to the next person who knows how to do the next job. And that was the concept of the assembly lines, introduced around 1913 or so. So this was about product movement through the production cycle. Then we got feedback controllers, 1930s, 1940s time frame, which would monitor the output and adjust the input accordingly. So it looked at either individual processes along the production cycle or just the end production cycle. Is the quality there? Can we keep it moving at the rate it's moving? Does it need to slow down, speed up? These were some of the early types of feedback controllers, and of course they became more and more advanced as we went along. And then next came networked systems. 1960s, 1970s, we started to see this. It became huge in the 1980s. And this is where our SCADA systems, for example, that we still use today, came from, and programmable logic controllers and things like this used in industrial manufacturing. If you're new to the concept of industrial manufacturing, I would really encourage you, even if your focus is going to be not necessarily on traditional SCADA systems and PLCs and HMIs and these kinds of things, then still go back and study some of those things. So if you haven't looked into it, it's good to study it, because sometimes what we don't realize is when people architect a new thing, they do it based on the old thing. And so as we're building IoT solutions, a company that has been involved in industrial automation for years may now move into the IoT space. And they're taking the expertise and knowledge base that they already have on staff, and they're pouring that into the way they're developing their IoT solution. So you'll see a lot of interesting correlations between the old way and the new way. And by understanding the old way well, you can often understand why something works the way it does, rather than just jumping into the newest thing. So I really do encourage you, do some studying into some of the older systems. A good solution for that, there are a few free magazines you can get, like Control Processing and Control Engineering. These are free magazines. They have all their archives online. You can go back and look. Some of them go back to the 90s. And that can allow you to go back and look, okay, what were they talking about in the 90s? What were they talking about in the first decade before IoT really took off of this century, and so forth. So looking into that stuff can help you better wrap your mind around it. Additionally, as we're going to talk about, one of the problems with industrial wireless is that it's often being implemented by the IT people and not the OT people. And when that happens, there can be a clash between IT and OT. And if you don't know what I'm talking about there, IT, of course, you know what that is, information technology. It's those who have traditionally done Wi-Fi networks, for example, right? Some subset of IT. OT is operations technology. These are the people who have managed the automation in the plant for decades. And so they have their way of doing it. And when we suddenly come in there and say, hey, we're going to be doing some IoT stuff here and it's going to be wireless, immediately there are concerns that are raised. Well, understand that those concerns come from pains they've already lived through. In other words, they're not telling you, you don't know what you're doing. They're telling you, we know what we're doing. And we need to listen to those OT professionals, because they have already gone through pains with wired automation systems, understanding how to get what they need out of those. And so they can help you understand the requirements and the mission critical components that have to be there in any wireless solution if it's going to work for them. So we definitely need integration between IT and OT to make it happen successfully. Industrial wireless then can be loosely defined as centralized industrial automation over wireless networks. It might not all fit into that automation category. Maybe we're not automatically doing anything. You may have an industrial wireless project where it's just about monitoring and no automated actions are going to be taken. Technically, that might not fall into the category of automation, but you could place it there by simply saying we're automating the monitoring. I mean, if you think about it, how did you monitor a boiler in 1900? You went up to it and you looked at the temperature gauge. Okay, so it was manual. If I can get the data from that temperature gauge to some remote location that I can see 50 temperature gauges for 50 different boilers, then I have automation. I don't have to manually go around to all of them anymore, right? It's being brought to me centrally. Of course, digitizing that data means I can have dashboards and all the rest. So many things do fit into automation, even if it's not about taking an action, because you can have the monitoring of that temperature or whatever it happens to be, and then have alerts that are sent to the appropriate people and so forth. So at least the monitoring part of it is automatic, and then someone may still have to go take some kind of an action. And by the way, the word automation, just in case you're curious about that, it's not an ancient word. You might think it is because, automate is probably pretty old, right? Well, automate is pretty old, but automation in common use really only goes back to the 1940s. Before that time, people might say they're going to automate this or automate that. But what happened was a company created a department. It was either GE or GM. I don't remember off the top of my head which one of those G's it was. But one of them said they're going to have an automation department. And that's really where, as far as we can trace, the use of the term automation goes back to. So we think of automation today as just a common term we use all over the place. But it's really only several decades old. And obviously, though, brings a lot of value to our organizations. All right, so what are these big three issues that I said we would talk about today in relation to industrial wireless? Well, the first one is security. This is a big concern. Again, as I alluded to, the OT people, remember the operation technology, these are the people who've been managing automation in industrial environments for decades. They have faced real severe security problems with their systems, with SCADA systems, with programmable logic controllers, with things like that in the early implementation phases. If you go back to the 90s, you can see all kinds of reports about security vulnerabilities in industrial automation systems and things like that. So they have gone through that. When we come along now and say, hey, we're going to be in charge of your wireless links within your system, it shouldn't surprise us that there's fear there, okay? Because they know that they've already dealt with it. They don't want to have to deal with it again. And as soon as you hear wireless, you think, oh my, this thing isn't even contained inside of a wire. That is scary. So it's very, very important to know that we need to address that issue. The second one is stability. So many of the communications within the plant environment, as well as outside of industrial and oil and gas and energy and things like this, stability is a very important issue because there are communications that have to be real time or near real time. And that doesn't mean we need to have massive amounts of throughput, but it does mean we need to get it through the connection and get it through in a timely manner. And then the third one is integration. That is being able to integrate our existing IT networks and our OT networks in whatever way is needed for that organization. And integration can be loose in many deployments and it can be tightly coupled in others, but it's something that we have to think about. So what are the security issues? Well, I think they fall into two overarching general categories: the protection of the transmissions and communications, and then the protection of equipment. So the issue with the protection of transmissions and communications, first of all, is that IoT protocols vary wildly. There are big differences between the way the different IoT protocols work when it comes to security. And we literally have dozens of different IoT protocols. Yes, there are 6 7, 8 of them that make up 85 to 90% of all implementations. But there are probably 15 of them that make up 97 or 98% of all implementations. And then when you get closer to 99%, you probably now have 25 listed, okay? So the point is there are a lot of different protocols. Some of these are standards-based, things like Zigbee and ISA 100.11a and Bluetooth, and some are just proprietary. One vendor creates a set of IoT solutions and they have their own proprietary protocol that they use for it. That proprietary protocol might be based on layer 1 and layer 2, 802.15.4, for example, or even their layer 1 and layer 2 may be their own thing. Now, we have a big move toward standards-based IoT protocols. We really do. If you go back in the early days, particularly if you go back to before it was called IoT, when it was just called wireless automation or wireless connectivity, and the biggest thing then was wireless sensor networks. So we started dealing with those before people really talked about IoT. It was around 2008 or so that the term IoT began to be very, very wildly and commonly used. Before that, IoT was heard of. Goes all the way back to the late 90s, but it wasn't until around 2008 when you start to see mass occurrences of it all over the place. Before that, we did have mass occurrences of wireless sensor networks. And so that was a big part of what was happening. Early on, think about it, it's wireless, right? So a wireless sensor is not as scary to us as a wireless actuator, because an actuator does something and a sensor just tells us something. So if we've got wireless sensors, that's not as scary because they're just reporting back to us what's going on. If we've got an actuator, the scary part is, well, if someone hacks into that and they can shut down the machine, or they can speed up the machine, or they can take other actions, then it could cause harm to people around it. It could reduce production time cycles, or increase production time cycles, and so forth. So there were concerns early on, obviously, but as we got security, it wasn't as big of a concern. But in those early days, there were proprietary things. You know, there were wireless protocols that started out as completely proprietary, that today are somewhat proprietary with a little bit of openness to them. I think LoRa would be a good example of something that fits into that. One company still owns the right to make the chips, right? But many, many people build solutions on top of LoRa now, not just one company. And that's LoRa, L-O-R-A. I'm sorry, my West Virginia accent comes out and I tend to call it Laura, like the woman's name. That's not my intention there. But the key then is that these protocols vary wildly. And so what we need to do is understand them. And we'll talk more about that under solutions. Some do unprotected over-the-air firmware updates. And this has been a problem for a few different protocols over the last few years, where for some reason, when it was implemented, they chose, and this is generally, by the way, how people implement the firmware update as a product vendor, not necessarily a protocol itself. So it's more the way the product vendor chose to do it. And so the vendor is pushing firmware updates to a wireless node, and they're not encrypting anything. There's no authentication. So it's open, and that has introduced some vulnerabilities over the year. Some have cumbersome onboarding processes. They may require scanning a QR code or a manual process to get each device on. Now, that's not a problem if you're only going to get 30, 40, 50 devices on and you've got a week or two to do it. But if you're going to put hundreds or even thousands of devices on and you've got a couple months to do it, that is a big challenge. So we need to think about the onboarding process there. And then some have weaknesses in the data path. And what I mean by this is not just in the wireless link. When you're looking at an IoT solution, you have to think about not just the wireless link, but you have to think about where does the data go once it reaches the gateway, the coordinator, the sync, the base station, whatever they call the thing that all the wireless devices talk to. So they send their data to that thing, and they receive data from that thing that I'll just call the gateway. That gateway then sends it off somewhere else, and the question is where. So it might be using an MQTT server, for example. It might be sending it off to some proprietary solution. It might be sending it straight to the cloud. Where does it send it? And what is the security like along that path and at that destination? So these are key important things to think about too. And then under protection of the equipment, really two things. One is that devices are not always designed for hostile environments, and industrial environments can be hostile from the perspective of particles in the air, temperature variations, things like this can impact the device. And the second one is they do not always have mounting options securing their location. So keeping people from stealing them, in other words, right? So let's talk about some issues or some solutions rather to these issues. First of all, protection of transmissions and communications. We want to make security part of IoT protocol selection. So as we're implementing our solutions, security needs to be part of the choice. Now, this is why some protocols rise to the top, because a lot of organizations, when they implement an industrial wireless solution, they often start with, what's everybody else doing? And so you'll see in particular verticals within industrial or higher level verticals, industrial versus healthcare versus energy, you'll see that one protocol seems to be the most dominant. And that often comes because of write-ups in magazines and things like that early on, when the first few companies implemented their industrial wireless solution, that's the protocol they used. So it kind of became the de facto protocol for that vertical. Or it's because the protocol organization, whether that's something like the Zigbee Alliance, the LoRa Alliance, or whomever, they really did a good job of marketing to that vertical. And so it got in there. It doesn't automatically mean it has the best security. So I know that makes it challenging for us, but just because it's the most popular doesn't mean it's the most secure. So part of this process is going to be to go out and take a look at CVEs, for example. So we can look at CVEs related to particular protocols. We can just do searches, using our favorite search engine on security issues related to whatever. ISA 100.11a, wireless HART, Zigbee, Z-Wave, Bluetooth, on and on. Generally speaking, the good news about a good search engine is you can narrow the search results to a time window, because I honestly don't care about vulnerabilities that were found in Bluetooth in 2005, right? If I'm not using that old Bluetooth anymore and it doesn't have that, the modern version doesn't have that problem. So filter it to more recent times, but still you need to do your homework. You got to go out and look for those issues. And the important thing to keep in mind is, while here at CWNP we create certifications, they're on a cycle, right? A 2 or a 3 year cycle. And so even if we tell you in the CWICP training class or the study guide, hey, these are some security concerns with this protocol, they may not be anymore 2 years later if you're using the most updated version, or there might be new concerns we didn't mention because they came along within that 2 year window of time. So it always comes back to us when it comes to security, having to do our research. Ensure over-the-air updates, if used, are encrypted and authenticated. So the big part of evaluation of not just the protocol, but the coupling of the protocol and your specific IoT solution is, are those updates encrypted and authenticated? That's going to help to prevent vulnerabilities there. Just because something's encrypted and authenticated does not mean there can be no vulnerabilities, right? So take, for example, a protected Acrobat PDF. So I can go in and say I want to encrypt it and I want to password protect it. But then there are cracking tools to crack it, right? And so now that's not a direct analogy to networking, but it proves the point that just because something's encrypted and authenticated doesn't mean it can't be hacked. If you're from a Wi-Fi background, think about WEP, right? So it was authenticated with a password, you might say. It had a WEP key or a WEP phrase to use for WEP encryption, and then it was encrypted, and yet it could be hacked in a couple minutes, right? So obviously, just because it's encrypted and authenticated doesn't mean our job is done. We still have to monitor and look for new security vulnerabilities and things like that. Evaluate the onboarding process to allow for mass onboarding when required. So if you are in a project where you're going to have hundreds or thousands of devices, then onboarding becomes an important thing. How do I get that device initially connected to the network? If it's a 10-minute process to get each device connected, that may be a problem. But don't assume the first onboarding method you see for a particular IoT solution is the only one. Often they might publicly list this as an option, but if you communicate with them, they'll say, oh no, for scenarios like yours, we have this option available that makes it much faster. Evaluate the data communication path for weaknesses. So if you're using an MQTT server, for example, in your IoT solution, is it secured appropriately so that people cannot hack into that MQTT server? Vulnerabilities in MQTT servers have made big news over the last 2 years, and it's not so much a weakness in the code, it's a weakness in the way it's implemented. And then always use authentication and encryption. Even though, yes, it doesn't guarantee your protection, it certainly minimizes the ability for someone to be able to attack you. And then for protection of equipment to deal with the harsh environments, we want to use IP-rated enclosures, IP67 or whatever's required for you, so that they are protected. And that's where, when you go to a website that sells industrial wireless gear, you'll tend to see those rugged enclosures on everything. They're designed with that environment in mind. If you're building your own solution, using Raspberry Pis or some other type of board, then you're going to need to look for enclosures that give you that good security if it is a harsh environment. And not all industrial environments are harsh environments, so it depends on your environment. And then ensure proper secure mounting to prevent theft and tampering. So if they don't provide some solution for that, what is your solution going to be? And part of what I mean by tampering is moving the device. So if the device is moved 3 feet, that could potentially put it in a place where its communications become unstable, which could be very problematic. So you've got to watch for that as well. All right, what about stability issues? Well, the big thing to keep in mind is industrial wireless does not always require wide pipes. In fact, quite often it doesn't require wide pipes, but it does typically require consistent pipes. So what I mean by this analogy of wide pipes is industrial wireless doesn't necessarily need a pipe that's 1 foot in diameter. It might be okay with a pipe that's a couple millimeters in diameter. It doesn't need to send a massive amount of data each time it communicates. But whenever it communicates, it really, really, really needs that to get through. Okay, so that's the big thing. Stability is very, very key in industrial wireless. Now, I'm not saying there are no wide pipe requirements. Sometimes you run into it, but the vast majority is about getting the data through. So the focus here is on the wireless link in this case. I'm not going to worry about once it gets to the gateway, where it goes beyond that. I'm talking about the wireless link here today. So some of the problems are links are inconsistent. Sometimes they work, sometimes they don't. Signals are weak. Depending on the protocol, that might reduce your data rate. And therefore, if that's true for many different devices, and all those devices are contending for the channel, the end result is you have greater delay when it comes to sending the data through. Or there could be too much interference. The wireless network is using channels or frequencies that many other devices are using as well. So as an example of this not necessarily needing a wide pipe, two of the most popular protocols in industrial wireless are ISA 111A and Zigbee. And most of them, the links are 250 kilobits per second or less. So it's not about having a huge pipe. There are other industrial wireless protocols that have a throughput of less than 100 kilobits per second. And that's their maximum throughput. And people love them because their stability is there. What they need is there. So we always have to keep that in mind, especially for those of us that may have come from the Wi-Fi space where for years it was all about how do I get a bigger pipe? How do I get a higher data rate, in other words? And with industrial wireless, it's about how do I make it as stable as possible and get the data rate that I actually need. So solutions. Gaining wireless link stability. Select protocols with adaptive noise immunity. I don't really like that phraseology, but let's talk about it. So with Wi-Fi, for example, if you are using Wi-Fi in industrial wireless, then you probably want channel monitoring and switching, some centralized system that is monitoring for problematic symptoms, like a lot of retries in the channel, and then can switch to different channels. The LoRa protocol, which is what takes care of the device to device, the RF link communications. LoRaWAN is what gets it the rest of the way on the network. But the LoRa protocol is all about the modulation at the PHY layer. And so it's about that RF link. And it has noise immunity in its modulation. But again, I think noise immunity is bad terminology, and it really should be noise tolerance, because I have yet to find anything that has noise immunity. Noise immunity means it can't hurt you, right? So at least that's our colloquial understanding of the term. So if I say I'm immune to the common cold, it means it's impossible for me to get the common cold. But if I have a strong immune system, I can say I am resistant to the common cold, or I have more tolerance to the cold virus, right? The point is that I'm not immune, but I'm less likely to get that cold. Well, that's why I like the term noise tolerance or noise resistance over noise immunity. And you will see the exact phrase adaptive noise immunity, by the way, in some wireless chipsets for Wi-Fi over the last 3-4 years or so. And I'm not really convinced about how great it is. But at any rate, the point is, when I'm talking about noise immunity in this context, I'm simply saying we need something to deal with RF interference on as much of an automated basis as possible. And so that becomes a big issue for those that don't like RRM or whatever you want to call it. I just like to call it dynamic channel selection. Okay, so simple generic term. So for those that don't like it, well, in industrial, if we have to have high stability, something like that is practically essential. Next, be aware of demands for time-sensitive networking, or TSN. So time-sensitive networking has been a pretty big buzz phrase in industrial networking for quite a while. I'd say 15 to 20 years we first started to see it discussed in the papers and journal articles and in more common publications, certainly in the last decade. The concept of time-sensitive networking is it's got to get there, and it's got to get there now. And therefore it has to be reliable too, right? So if it's time sensitive, I need to get it there within a time and with synchronized time. And therefore the network has to be there. That's the first requirement. So there's reliability, but also the network has to be there for me. In other words, if I'm the communicating device, it has to be there for me. Now with IoT protocols, the big thing we're asking is what QoS offerings do they have? So most IoT protocols you won't see time-sensitive networking in the standards documents or in their actual terminology that they use, but you will see QoS, and that's what we're talking about. So we need to make sure that any devices that are time-sensitive, that QoS is configured appropriately for them to be able to function as well as possible. And because some wireless systems QoS is, let's say, more like wired than others, then that might be a big factor in choosing your industrial wireless protocol. And then the big thing is, this goes back to the traditional Wi-Fi stuff we've talked about even for office spaces, right? Design before you implement, validate during implementation, validate after implementation, and then monitor. So if we want a stable industrial wireless environment, whether we're using Zigbee or something like Monit's proprietary protocol called Alta, or some other protocol, whatever we're using, we need to design based on the parameters of that protocol. In other words, it works with particular frequencies, it uses particular transmission powers and things like that. Design around the constraints of that protocol. Then while we're implementing, we're validating, and then when the whole thing's there, we're validating, making sure everything is good. And then we need to do ongoing monitoring. Some of that would hopefully be automated so we get some noise immunity built in, but we need to do monitoring after the fact. All right, let's talk about our last of the big three, and that's integration issues. Here's the thing. According to Belden, which is an organization that's heavily involved in industrial automation, providing both platforms and hardware for it, and their white paper called Advanced Security for Industrial Networks, they talk about the OT network, and when we begin to integrate with IT, some of the things that we have to think about. And that is, the OT network was designed from the ground up for high availability, and many of these were wired, right? So as long as the wire is connected, it works, kind of thing. And it's interesting because when you start to study some of these older wired OT protocols, a good example is HART. HART is a wired protocol often used in OT networks, and wireless HART is the wireless version of it. But the funny thing is, the actual speed of wireless HART is faster than most HART implementations. So it's wireless, but it's faster. Because again, for these OT networks, it wasn't about, oh, I need 1 gigabit links to each device, or 10 gigabit links, or even 100 megabit links, or even 10 megabit links. It was about, I need a stable, consistent link that will go sometimes over a great distance. So high availability was key for them. The the IT security and compliance becomes a big issue for us. And what I'm saying about that is when we're implementing wireless, industrial wireless, we need to think about high availability. And then there's IT security compliance. So we have our security rules, right? And then OT has their security rules. If we're going to integrate the two networks, now we've got possibly conflicting rules. So we've got to think about that. Convergence of legacy OT and IT is a big issue then, and the lack of visibility into the OT network or OT operations can be an issue. So IoT systems are often designed to stand alone. They're not really designed to integrate with something. So we have to think about how we're going to do that. It sometimes is a mission of IT instead of OT. So now we get different people that we have to deal with. And then there are those existing OT networks, as I've just talked about, and IT-OT integration becomes important. So let's talk about this. The first thing I would say is begin by addressing the IT-OT coexistence or integration issues from an organizational perspective. So go up a little higher in the umbrella. Don't go to the top of IT and the top of OT. What's next? Let's bring together these leaders and then key people within each of these operational segments and have them figure out how we're going to work together, because it is absolutely essential for us to be on the same page. So start with an organizational perspective. If you don't have that kind of buy-in from management and so forth, you're going to face significant challenges along the way. The next two steps, know your environment and assess your environment. Know your environment is, if I'm the IT person and I'm asked to go in and help with the implementation of IoT, well, I need to know what they're already doing. I don't want to interfere with it. I don't want to conflict with it. And I don't want to do it again when they're already doing it and they're not going to stop doing it the way they are. So for example, if they've already got a system that monitors those boilers we talked about earlier, right? And if I implement an IoT solution that can monitor them and they're not going to do anything different, then I really need to think about the value of that. Now there might be value. So my IoT system might be monitoring it just to report up to some executive or manager who wants to monitor statistics about it. And there's no way to get it out of the current system that's doing it the old way. And they want me to just go around and implement some temperature sensors on the boilers and do that. So there might be some reason for it being separate, but I need to know what's there. And then that's assessing the environment. So when I know what's there, then I can say, do I need to complement it? Do I need to supplement it? Do I need to replace it? Or do I need to simply coexist with it? So how are we going to deal with implementing the industrial wireless components we're building? So what are the integration solutions available to us? Well, we have to think about centralized data store and processing. So one of the big components of integration is getting data from disparate sources and bring them together into an aggregate format that can be beneficial or useful. And there are different ways that we do that. Sometimes it's on premises. Sometimes it's in the cloud, but we have to think about how we're going to accomplish that. Sometimes we have something between all of the different systems in the cloud. So we might have various different systems that all report to an edge or fog computing system that then takes that data, processes it, transforms it, and then loads it into the cloud. Okay, so there may be a lot of those good old traditional ETL database operations taking place here. And this is where at least some high-level understanding needs to exist for someone that's going to be heavily involved in IoT. They need to understand database systems. They need to understand programming environments. They need to understand data transformation. They need to understand data transfer. All of these concepts are very, very key and important. And by the way, I'm not going to get into it heavily here today, but if you're foggy about fog computing, I did write a blog post about that at CWNP a month or so ago. So if you've heard the phrase fog computing and you've struggled to figure out what in the world is it talking about, well, go on my struggle with me, because in the blog, I take you through the process of thinking it through that I had to go through to come to the conclusion of what fog computing is. Went through that process some time ago, but documented in the blog about a month or 2 months ago. So check that out. And then finally, there may be the need for a DMZ implementation between OT and IT based on some of these conflicting security policies that might exist. We in IT may be allowed to do some things that OT is not. And we may not be able to gain any type of agreement on changes in either our or their policies. And so the only solution might be that there's a DMZ between us And then in that DMZ is our data aggregation point. So we can put IT data into the DMZ and OT data into the DMZ. Now in this context, I'm not saying between your network and the internet. I'm literally saying between your internal OT network and your internal IT network. Okay, so don't think of the DMZ of, well, if I create this, doesn't it put it out there where it's just right there at the edge close to the internet? The concept of a DMZ is just that it's a demilitarized zone, which has some type of separation, usually a firewall between it and another network, and then it and another network, right? So it's like got these two barriers on either side of it, if you will, or it could be more than two. So in this case, we're implementing the DMZ between our two networks. And then we're taking data that's okay with OT policies to go into the DMZ and pulling it out into IT. And then we're taking data that's okay with the IT policies to go into the DMZ and putting it over into OT. Sometimes this can be a transitional solution. Sometimes it's the permanent solution. But it is something that you'll definitely have to consider when it comes to integration of solutions. All right, that's all we have scheduled to cover today. So I'd like to thank you for attending.